Hello, I am Professor Dr. A. Mirza. Let us study the sections of solids. Now, what is the prerequisite for this section of solid is that before studying the section of solid, you must revise the following concepts. The different types of solids, just like prism. The different prisms already we have studied: triangular prism, square prism, pentagonal prism, hexagonal prism. Similarly, triangular pyramid, square pyramid, pentagonal pyramid, hexagonal pyramid. Again, we have studied the cube and polyhedra also. Then cylinders and cones. Some nomenclature is equally important for the prism. There is one top and one base. So it is square prism, square top, square base. Pentagonal prism, pentagon top, pentagon base, and so on. Then there is one rectangular face here for the prism. This is the one rectangular face. Out of that, this is the longer edge. For the base, this is the corner of the base. This is the edge of the base. Similarly, for the square pyramid also, there is only one base here. No? So this is the edge of the base. This is the corner of the base. Now instead of another top which is there in the prism, so there is only one apex here in the pyramid. So these apex points are joined at the corners of the base, and due to which slant edge is there. There are four slant edges in the square pyramid, and due to slant edges again, what triangular face is formed. In the prism there is rectangular face, while in the pyramid there is triangular face here, which is joining the edge of the base and the apex here, and this particular edge which is longer is slant or inclined here. Similarly, for the cylinder and cone, now these are the additional generators. These are image lines which we require. For the cylinder, there is one circle at the top and circle at the bottom. While cone, there is circle at the bottom, that is the base, and the apex is there, and the apex is joined here. And then different types of sections we can see: section of cone, section of cylinder, section of pyramid. So these different types of solids you should study. Then rules for simple position, rules for inclined positions. When the axis is inclined to one plane parallel to other. Similarly, when the axis is inclined to both the planes HP and VP, then you must revise the rules for the visibility. And at the end of this lecture, you are able to understand section parallel to VP, section parallel to HP, section plane perpendicular to HP and inclined to VP, and section plane perpendicular to VP and inclined to HP here. Now in the section of the solid, let us see the first case, section parallel to VP. Now we are going to see the simple case of the cube having the side as 35. It is given as resting on the HP on one of its faces. Now there are 6 faces now. So one face is here at the bottom. Now that face is to be drawn here in the simple position. Now in the HP, so these are the points. So at the top of this cube, there are point ABCD, ABCD. Similarly, EFGH. Now this EFGH is on the reference line, and this EFGH is drawn initially in the true shape. So while drawing the true shape of the base, now we know that this angle is 90. But what is the additional condition given is that so vertical face is inclined at 32 VP. Vertical face inclined at 32 VP. So these are the two vertical faces, for example. Out of that, this particular vertical face, if I extend, so this angle should be 30. So take this any point at convenient distance, draw this line at an angle 30, take length of this side of the cube, then draw line perpendicular this, again perpendicular. You can complete the true shape of the base. Then take the point A here as A dash, C here as C dash, B here as B dash, D here as D dash at the top. So while taking this, so this is the side of the cube again. All these 4 points are already taken here. Is E, F, G, H, bottom points. Top point A, B, C, D you can take here and complete this view in the front view. Then the cutting plane is given here. So it is cut by the section plane parallel to VP. So when it is parallel to VP, it is perpendicular to HP. So when this cutting plane is perpendicular to HP, in the HP you can see the edge view. Now this edge view is parallel to reference line at some distance. What is the distance given? 9 mm away from the axis. 9 mm away from the axis. Now how to decide this now? Now this is the point O, which is the axis of the cube here now. How to decide this? Once you have drawn this true shape of the base, so AC and BD diagonal you can join. So intersecting point is this point, that is point is here and another point here. So in the top view, so these 2 points are matching and the axis is here actually. From this axis, so this section is given the 9 mm. So from this point you take 9 mm here, and through this point you draw this edge view. Now remember, so this particular cutting plane, which you can see here now, this cutting plane is cutting at 4 points, 1, 2, 3 and 4. These are the section. Now these 2 points you can see at one location, and other 2 points you can see at another location. So these 2 points are 2 and 3, and these 2 points are 1 and 4. So in the top view, 2 and 3 will match. So this is 3, this is 2, this is 1, and this 4. You see 1 dash, 2 dash, 3 dash, 4 dash, 1 dash, 2 dash, 3 dash, 4 dash. So these 2 and 3 will match here in the top view. So 2 is here, 3 is here. Then 1 and 4 will match here. So 1 is here and 4 is here. So 1 dash, 2 dash, 3 dash, 4 dash is the true shape of the section. Now why it is true shape? Because this edge view is parallel to the reference line. So other view is the true shape. So this completes this particular question. So start with position 1 and then you can draw the second position. Take the edge view of the section plane and locate this 4 point. This is the true shape of the section. So this is the case when the section plane is parallel to VP. When the section plane is parallel to HP now, so this is the second case now. Now in this triangular prism, base side is given as 30, that is this one, axis 50, that is this. It is lying on the HP on one of his triangular rectangular faces, sorry. So this rectangular face is there. So first we can draw this, initially you can draw this as the triangle in the true shape. From that you can take the projection here and then you can complete this view here. So 3 points are here and 3 points are here, means A dash, B dash, C dash, E dash, D dash, E dash and F dash. So then once you draw this view with rectangular face on the ground, that is this rectangular face is on the ground, then it is cut by horizontal section plane. So when the section plane is horizontal, so you can see the edge view in the VP now. So in the VP you can see the edge view, and this edge view is parallel. So it is cutting A dash, B dash, C dash at point 1 dash and 2 dash, that is these 2 points for example. And here another triangle is there, it is cutting for the triangle at 2 points, 3 dash and 4 dash. So 4 points are there, 1 dash, 2 dash, so this 1, 2. So 1 is on AB, take here. 2 is on AC, take here. 3 is on DF, you can take here. 4 is on DE, you can take here. So these are the 4 cutting points here, 1, 2, 3, 4, and those 4 points are taken here. So this is again true shape. So why it is true shape? So this edge view is parallel to reference line, so that's what is the true shape here. So here the section plane is parallel to HP. So edge view you can see in the VP. So start with edge view and then you complete this as the true shape here. Then next case, section plane perpendicular to HP and inclined to VP. Now again we are taking the same example of the cube now, but now this particular cutting plane, which was initially parallel to the reference line, now it is inclined. Why? Because it is inclined to VP. So angle with VP you can see in the HP here. Angle with VP you can see in the HP here. So that's why take this edge view through which point. So for that the condition is given that condition is given cutting plane is inclined at 60 to VP, so that angle you can take here, and perpendicular to HP, so edge view is in the HP here, so that face which makes angle 60 with VP, that is this face is making angle 60, this face is making 30, and this face is making 60. So this cutting plane cuts in 2 parts, that is this point. So this point is the midpoint of this. So through this midpoint you draw this line at an angle 60. So it is cutting at this point. Now this 1, 4 is 1 dash and 4 dash here, and this 2, 3 is 2 dash and 3 dash. It is cutting at the 4 points, 2 points here, 2 points at the top, 2 points at the bottom. So at the top point 1 dash, 2 dash, at the bottom 3 dash, 4 dash. So 1, 2, 3 and 4. Since this edge view is not parallel to this, so it is not the true shape. So it is the apparent shape here. How to find the true shape? Draw this line x1, y1